Hey, welcome back, everybody. I am really excited to introduce our next speaker, Om Moolchandani. And Om is the co-founder and both the CISO and CTO at a company called Accurix. And at Accurix, he is trying to help build out and helps to build out a modern cloud security solution. I won't go through all of Om's history, but at some point in the past, he also worked at Cipher Cloud, where he helped to architect the world's first cloud access security broker, CASB. So Om has a history of working on cool product categories. So Om, I'm going to turn it over to you. Thanks for being here.
Thank you, Frank, and appreciate so much. I'm going to quickly share my screen and bring my screen up. And I'm hoping my screen is visible.
Yeah, we can see it. Perfect.
All righty. Appreciate so much, and thank you, everyone, and welcome to my talk on self-healing infrastructure, GitOps, and Terrascan. My name is Om Moolchandani. I'm the co-founder, CISO, and CTO at Accurix. As Frank mentioned, I've been in cybersecurity now since over 17 years and have been practicing cybersecurity both in terms of the implementation as well as on the compliance and practicing side as well. My favorite attack technique is waterhole attack. Just a bit fun fact about me. Of course, I love cybersecurity, but I'm also a mechanical keyboard enthusiast. And I build all my keyboard myself. My favorite switch is a Holy Panda with SA keycaps. So what are we going to take a look into today? So we're going to understand how containers and Kubernetes systems are built, especially using modern methodologies like GitOps. We also will understand what is policy as code and how it can help us secure our Kubernetes systems really ahead of time, even before they are built. And we're also going to see a cool demo today with a very good GitOps tool called as Argo CD. And we're also going to see an open source project called Terrascan, which can help us implement policy as code use cases in Kubernetes environments. So let's understand how containers are built and deployed on Kubernetes, especially using GitOps methodologies. So any kind of container image or container that you want to build, of course, requires some level of application code, and it requires some other type of software as well to be packaged together. So as a first stage, when you are in your local development environment as a developer, you would write your application code. This code has to be checked into some kind of source code management system. It could be a Git-based system, or it could be a non-Git-based system. For reference, I'm going to just speak about a Git-based system here. Once your application code is in your Git repository, the next steps are to build a container image out of it. So the application may require compilation or may not. It has to be packaged. So you would be using some sort of Docker file, base system to compile and also package a container image. This is a phase which is called as the build phase. Once the build phase is over and your container image is ready, the container image can live in a container registry or in some other sort of storage system of your choice. Typically, we see that organizations love to use container registries, which has an interface, a very known API interface called as DTR interface, which was developed by Docker. Now, once the container image lives in your registry, that's when you are ready to write something which is called as IAC, or infrastructure as code. Infrastructure as code will allow you to declaratively define how you would want this container image to be deployed on a given cluster, on a target cluster. Now, infrastructure as code can come in various different shapes and forms. For Kubernetes, most of the industry uses either YAML files or Helm charts or customized templates, customized with K. So once you've written your infrastructure as code, you can now declaratively define in which namespace you want this container image to be deployed, what should be the other parameters, your configurations, everything can be declaratively defined there. But once you've written your infrastructure as code, it has to also live in your source code management system. So you check the code in, you check your infrastructure as code also into your Git repository. Once you've done that, after that comes the turn for the operations. So remember, now you've written your infrastructure as code and it is living in your Git repository. Now, once the operations phase come in the operations phase, you're going to have a phase which is called as sync or deploy phase. This is a phase which will pick up your infrastructure as code and will sync your cluster with the state mentioned in the infrastructure as code. What it means is that now you are doing Git and operations. And that's why the tools which allow you to achieve this objective within this phase are called as GitOps tools. So the GitOps tools such as Argo CD, Flux, and many other out there allow you to sync the state of your cluster with infrastructure as code that you have available in your repositories, in your Git repositories, essentially allowing you to operationalize your Git repositories into translating them into real cluster configurations and syncing the state of your cluster. Now, at this stage, once you have operationalized your GitOps tool, the developer just has to keep pushing changes into the Git repository without worrying about how they're going to get deployed onto the cluster. So no need to worry about kubectl apply. Basically, the GitOps tool is going to do that job for you, but with many other capabilities. Now, this is a scenario which is leading us towards a no ops scenario. Of course, this is not no ops. This is not zero ops either. There is an element of operation and there are nuts and bolts still that need to be deployed. But then the industry, in my opinion, is moving towards a no ops scenario. Maybe in a few years of time, we will see more transparency and we will see that the operations will become totally transparent to the application developers in such a way that there's absolutely no involvement of application teams whatsoever. But that's not the case today. But this is a considerably different scenario from DevOps. So therefore, GitOps is leading us towards that situation. Let's take a look into Argo CD, a really quick look into Argo CD and how it looks like. Argo CD is an open source project which allows you to do GitOps on Kubernetes environments. It comes with a ton of features. Of course, the most important one is the fact that you can tell Argo CD what are your target Git repositories, which are holding your infrastructure as code. And from there on, Argo CD can continuously sync them with your clusters. Argo CD can be deployed in many different ways. We're not going to go too deep into Argo CD. I wanted to give you guys just a quick glimpse of how Argo CD works. So the traditional deployment scenario is that you're going to have Argo CD deployed in your clusters. And then from there on, you're going to mention Argo CD, what are the target repositories, and you're going to be able to sync from there on the repositories and the clusters. You could segregate your repositories by namespace and many other strategies. I will let you explore how Argo CD works from their GitHub page. Once you have your GitOps tool deployed, how do you ensure that you are actually deploying all your infrastructure as code in a safe and secure manner? That's where policy as code helps. And policy as code is a strategy which allows you to declaratively define the policies that you want your infrastructure as code to enforce as well as to comply with. Policy as code is a method which is typically used in automated workflows since it's a very low effort strategy. Basically, the policies are stored as source code, they are versioned, and then you define your policy enforcement throughout the life cycle of your infrastructure as code development, as well as Git management, and during the GitOps deployment lifecycle. Why policy as code is very, very useful is because it reduces your cost of remediation tremendously, because you can detect your security problems now, even before your target environments have been built by analyzing your infrastructure as code. It allows you to do a very low cost governance model by enforcing the policies on GitOps pipelines. So you're going to ensure that your pipeline, your GitOps tool, does not move forward unless there is compliance of policies available. And of course, because you can declaratively define the policies, there's a lot of flexibility that comes with it. For example, if you want to ensure that your secrets are not used as environment variables, you can write a policy for that and enforce it. Likewise, if you want to ensure that you do not have any privileged containers going into your runtime with super capabilities, you can write a policy for that, and you can enforce it even before the runtime is built. So not only you are doing early detection, but you're also reducing your mean time to remediation, which is one of the biggest reasons why breaches happen. A lot of times when the breaches happen in your cloud environments, they happen because of the flaws, vulnerabilities, or misconfigurations, which are not necessarily unknown to the security team. In a lot of cases, the security teams have visibility to them, but because by the time they are detected, the runtime environments have already been built, so the opportunity to remediate is not available immediately, and the mean time to remediation increases. That is what you can reduce by adopting policy as code strategy. We're going to take a look into our open source project called Terrascan, which is a policy as code engine. It's built over a foundational technology called OPA, Open Policy Agent, which is a CNCF graduated project now. We in Terrascan have gone ahead and utilized OPA's capabilities to allow OPA to be implemented for all different type of infrastructure as code. And Terrascan integrates with various different kinds of tool chains and tool sets. Let's take a quick look into Terrascan. So Terrascan is a Go-based tool which is developed over OPA. Comes with over 500 plus policies, pre-codified, to be utilized for various different kind of environments, including Kubernetes. So with Terrascan, you can do policy as code, not just on Helm charts, customize, or YAML files, but also on Terraform and other infrastructure as code technologies. So that means you can use Terrascan to do policy as code for all sort of pipelines, whether they are being done for building your cloud control planes or your Kubernetes control planes, or a few other type of control planes as well. That's a power of doing policy as code. And you can detect a lot of security issues really early ahead in the development lifecycle. Let's take a quick look into how Terrascan integrates with various different tool chains. So Terrascan, of course, can integrate with Argo CD. I'm going to show that in the demo. It also can integrate with tools like Atlantis, which is another very cool open source project to do your pull request automation on Terraform. And it can also integrate with various different kinds of source code management tools as well. So you can catch your security problems even before the GitOps pipelines kick in. You could do that as well. Also, Terrascan comes as an admission controller as well. So you can also do last mile enforcement for certain selected policies. Let's take a quick look into how the policies look like and how you can codify. So I'm looking into a typical policy here, which is going to be checking whether you have app armor profile enabled or not for your cluster, for the given target pod and target namespace. So this particular policy that you're seeing uses a policy language called a template written in a policy language called Rego. Rego is the language for OPA. And if I quickly open up this Rego template that this policy is referring to, this is a template which is going to check whether you have app armor profiles enabled or not. You can write your various different kinds of policies. As I said, Terrascan comes with a lot of different open source policies in various different target technologies. So AWS, Azure, GCP, Kubernetes, many different types of Kubernetes security scenarios are already covered. And you can very easily code your policies, custom policies as you would want. So now that we have some basic understanding of how policy as code works, and we have taken a look into an open source project called Terrascan, let's understand how we can operationalize policy as code. So in this diagram, you can see that there are various different opportunities available to operationalize your policy as code strategy. You could do that even before the code is checked into Git repositories. You can use Terrascan as a CLI, and you could ask your developers to start scanning your infrastructure as code before before the code is checked in. You could use Terrascan also as a VS Code extension. However, that may not be scalable so much because not every developer would want to perform that kind of scanning. You can also integrate Terrascan with Git repositories directly, GitHub, GitLab. But you can also do is you can integrate Terrascan as policy as code between the stages of build or between the stages of sync and deploy. We're going to take a look into how we can actually integrate policy as code at sync and deploy stage. But we can do that, but we can also integrate Terrascan at earlier stages as well. So it totally depends on your strategy, your appetite. As you move forward in the stages, your cost of remediation will keep on increasing. Your cost of remediation is lowest at the stage number 1, and it gradually increases as you move forward in the stages. It's highest when you detect the problems in runtime. The last stage that we propose in the policy as code strategy is the stage number 7 here, which is your admission controller. So at the admission controller level, you would be able to do enforcement, of course, make sure that you're doing that with care, with a lot of care, because you don't want every policy to be enforced at admission controller level. Now, we're going to take a look into stage number 6. Let's do a quick demo of how Argo CD works with Terrascan. So what you're seeing on the screen is a sample application. This is a sample Python application that we are going to basically package in a container image. We're going to use Argo CD to sync with the repository, and we're going to see how Terrascan can be used within Argo CD framework to make sure that before this application is deployed, all the security scanning happens. And then if there are violations, of course, we can break Argo CD process as well. So in this particular demo, we're going to take a look into a simple YAML file as an ISC. This is the YAML file, which is a deployment YAML file, which you're going to use to deploy the application. Now, what we're going to do is we're going to copy the repository here, and we're going to go to Argo CD. We have already gone ahead and deployed Argo CD on a GKE cluster, and we are going to add this repository to the Argo CD, which you can see on the screen. Basically, we want Argo CD to continuously sync with this repository in terms of its state of the cluster. Now, here you can see that we have done some deployments already. This is the Argo CD interface. Argo CD has gone ahead and done one run of the deployment. The application has been deployed. We're going to do the second run for the deployment, but this time we're going to make sure that we have injected policy as code processes in between. So the way we're going to do it, Argo CD comes with multiple different methods to do your policy as code or your integrations. We're going to use something which is called as pre-sync webhook. So pre-sync webhook is nothing but basically a quick way to stand a new container image within the Argo CD deployment system. And that container image will be used as an intermediate stage by Argo CD before it deploys the infrastructure as code. It will be passed onto this container image, which is going to scan the code, apply the policies, check for the policy violations, and will fail the build if the policy violations are discovered. So what you're seeing right now is a pre-hook YAML file, which is going to deploy Terrascan within Argo CD ecosystem. So what you're seeing is that we are actually creating a quick Terrascan container image here. We're pulling the image, and then we are going to deploy a pre-sync webhook. This is the YAML file to deploy the pre-sync webhook, which will contain Terrascan, and Terrascan is going to then perform the scan on infrastructure as code. So we have this YAML file present in this particular repository. We're going to do some additions and some check-ins here. We're going to check this code in. As soon as we're going to check the code in, because the repository is already in sync, Argo CD is going to automatically detect that and will create a new pre-sync webhook. So we just did the push, and now we will see as we do the sync here, we synchronized. Now with the synchronization, sorry, I will just go. So we've gone ahead and done the synchronization. We're going to do the sync. In this sync, what's going to happen now? A new pre-sync webhook is going to get created. You can see the Terrascan hook has been created. This hook is going to now perform policy as code assessment. And when this assessment will be performed before the repository can be synced from its state point of view with the cluster, we can see now that Terrascan pre-sync webhook has performed the scan and has also failed the sync from happening. And why it is being failed? So we can take a look into the logs, and we can see various different issues are detected by Terrascan. This way now you will be able to ensure that your clusters are built either securely or not built at all. Of course, as I described previously, there are multiple strategies you can adopt. You can run these policies in a non-blocking way as well, only in monitor mode. You can also apply these policies at a much earlier stage as well, if you want to save some time on the development process. However, certain key policies which you absolutely do not want to be violated can then be enforced in your Argo CD pipelines or as a last mile enforcement on the admission controllers. So that's what I had for today. Hope everybody enjoyed looking into how policy as code works, and happy to take questions now.
Hey, that was great. Really enjoyed that demo and the tour of the different tools, and looking at Terrascan. And it's great for people to have a free and open source option like that. I think some folks listening in didn't realize that it was free and open source. Now, you mentioned that it's based on Open Policy Agent and the Rego expression language. There is a question. Can you talk a little bit more about kind of how Terrascan uses OPA, and what the question is, what are the differences between them? But yeah, how does Terrascan enhance OPA?
Absolutely. Let's take a look into a sample policy to answer this question. So I'm going to go into AWS, and I'm going to quickly take a look into a sample policy, which is supposed to be checking whether you have any port open to internet or not, right? What we have gone ahead and done is we have templatized the Regos. So here in this particular case, you can see that we are taking certain parameters in this Rego file, and we're going to check that parameter for your check condition or for your policy condition. Now, if you have 100 different ports or 100 different CIDR blocks to be checked, you don't have to write 100 policies. One single policy that you've written now is going to do that job. All what you have to do is basically use the same template again and again, and you can use that template. You can pass that template. This is your policy JSON file. You can pass the template and you can pass the parameters. Like in this case, I'm checking whether port 22 is open to internet or not. I can check more ports here. I don't have to write the policies, regos again and again. That's one big difference. The other enhancement that we have made is that now that you've written a policy for AWS, this policy is going to work not just on one single type of ISC, but on multiple different types of ISC. It will work on your Terraform. It will also work on your CFD or any other ISC that you will be selecting to write your code. The reason for that is because we also have built a middle layer in Terrascan on top of Rego and OPA, which normalizes all type of infrastructure as code into one single format. And so you don't have to write different policies targeting different sets. So therefore, once you've written a policy for AWS, it is going to work across the ISCs that you can choose to write for AWS. Likewise for Azure, GCP, GitHub, or Kubernetes. No need to write multiple policies.
Great. Hey, you showed the example of Argo. What if a team is using a legacy CI/CD tool like a Jenkins, or what's the support for these other tool chains?
100% fully supported. So Terrascan, can work with traditional DevOps tool chains as well, such as Circle CI, Jenkins, and many others. Terrascan also fully supports piping the plan output. So if you want to use a traditional pipeline like Jenkins for deploying, let's say, Terraform, then you will be going through a TF plan stage. You just pipe the TF plan into Terrascan in one of the jobs of Jenkins, and it will work seamlessly from there on. Similarly, you can do the same for your Helm charts and for your customized templates. You can pass the builds to the Terrascan job. Terrascan runs as a job as well. It's available on Circle CI Marketplace as well as a Circle CI orb. And you can also install Terrascan as a job on Jenkins.
Great. Well, hey, that was an awesome presentation. Really loved how you talked about kind of operationalizing policy as code. That was amazing. And a lot of good best practices for people to think about as they evolve their practices and their program overall. So let's go ahead and give a virtual round of applause. Thank you so much for taking the time to join us. Loved the presentation, and we're gonna go ahead and switch the conversation over to Slack now.
Appreciate it. Thanks, Frank, for having me.
All right, thank you.